Okay everybody, here we are at Horton, Bluff, Nova Scotia. We are standing on the ocean floor on the Minas Basin of the Bay of Fundy. That's the Minas Basin out behind me. High tide was just a couple hours ago, so it's 3 p.m. right now. High tide was 12 p.m. and over the next couple hours, or over the next almost 12 hours, the tide's going to go way out, hundreds and hundreds of meters before it starts coming back up again. And the tidal range here is about 12 meters or 40 feet, so just a huge tidal range. Okay, so behind me, if you can see all the way over, is the cliffs of Blomiden. All right, and then what you're seeing right here is the expanse of the Minas Basin. Okay, so here we are standing on the seafloor right now. It's exposed because the tide is going out, and in 12 hours from now, this will all be underwater again. But because of the huge tidal range here, it leads to a massive amount of erosion on this cliff face. So this cliff face is eroding back over time. Every year we come out here, it almost completely different because there's so much erosion happening. And one thing that's really neat about it is that you get rock eroding down onto the seabed here, and you can see all around me we've got these pretty large pieces of rock, okay, here and here, and they're all scattered about amongst this finer grained shale material, this sort of more pebbly, finer grained stuff. Okay, so I'm standing over here now. We're looking at what you can see down this long expanse of the outcrop. It extends in that direction for about 500 meters or so, and back in the other direction for quite a long way, for a couple kilometers in fact. But I'm standing right here because I wanted to point out this feature. See this rock sticking out? So we've got kind of a competent silty sandstone here, and it's actually undercut. It's eroded underneath by the water that actually comes up. During a very high tide, the water comes all the way up here. And you can see, as you look further down, you can see that undercutting where erosion is attacking the rocks from underneath. And that's part of what's happening with the overall erosion, and why this cliff face is eroding back so quickly with the tidal activity here. So I just want to point out something about the overall geometry of this package of rocks, because you can't really see it from where we're standing right here. But this package of rocks, it thins to the south of us. So south is that way, that's the direction of Halifax, and it thins and onlaps onto the basement rocks of the Maguma supergroup. And this rock thickens to the basin, so that way is the Minas Basin. The rocks thicken out that way, and so it's a big wedge like this. Okay, and so I'll show you a diagram of that in the video, and we know that from seismic lines, so from seismic evidence, and from the odd borehole that's been drilled on land through those rocks, we can start piecing together the overall geometry of this package of rocks. Okay, so we just talked about the overall geometry, the wedge-shaped geometry of this package of rocks, as I try to mimic a triangle with my hands here. The next thing I wanted to point out is the layering of the rocks. Okay, so we've got these nice horizontal layers, and you can pick them out. You can see that this layer is dipping just a little bit in this direction, which is to the east. And if you were to follow it, and you'll see it in the drone imagery and in the gigapan imagery, you'll see that those layers are dipping just a little bit, and you can trace them all the way along. So for example, up here we've got this layer of rocks. There's sort of it's eroded back a little bit more, the darker rocks, and then you've got some more tan, buff-colored rocks. So they're above my head if I was standing right here. But they dip down just a little bit, and they dip down below the level of the sediments here at the seabed. Okay, so we were just talking about the layering of the rocks, and one thing that's nice about this little part of the exposure here, there's a little embayment or a little alcove, and you can kind of get more of a sort of 3D picture of the layering of the rocks and the overall 3D structure. So we're going to move closer and closer towards the rocks, and and try to pick out some more features of the rocks. But one thing I want to point out is that above us, there's all this brown quaternary sediment. Okay, so the brown quaternary sediment sort of washing down the cliff face. You can see it up here. It looks brown, but the rocks aren't necessarily brown. That's all the junk from above that's washing down. So when you're looking at this overall outcrop, just keep that in mind when you look at the drone imagery and the Gigapan imagery. Don't try not to get confused by the brown material that's just washing down from above from the actual bedrock itself. So bearing in mind the issue with the brown stuff washing down from above, we want now to look at the different sedimentary layers of rock. And we're going to be talking about the concept of facies and clasts. So a facies is a package of sedimentary rocks that shares common characteristics. So common grain size, common texture, common chemistry, common trace fossils and body fossils, for instance. So all sorts of features that a package of rocks shares in common. Color is even one of those, and that's one of the things that you can actually see here once we get in a little bit closer. So we're actually looking at three main facies. We've got green shale, and this is all the stuff from my feet all the way up to just about up here, just above my head. And that gets into another facies. It's a black shale facies, okay? And that's that very fissile material that's behind there. And then above that, you can see the bits of rock that seems to be a little bit more competent, a little bit more intact and sticking out a little bit more. Those are sandstone layers, so that's a third facies. So three facies again. We've got a green shale, a black shale, and a sandstone, so three main facies, and we'll look at those in more detail. Now you can't be here in person, so I'm going to be your eyes, and in some senses your sense of touch, so you can feel the rock. And we'll put together our observations, and I'll help you with those observations, and then your job will be to put those observations together to make some inferences about where these rocks came from, what kind of depositional environment led to the formation of these rocks, and more particularly why we get the specific layering of the three different facies. They occur in a very distinct order that repeats over and over and over again. So we'll have a look at the characteristics of those individual facies, and then we'll try to put it all together. Okay, so we're standing at the green shale. So this is the first of our three facies. And you can see that it's pretty green. You look at it in color, it's pretty green. Now, don't forget, there's all sorts of brown material in here, and that's all coming from way above. So it's this color right here that we're referring to when we say green. It's kind of a grayish green, actually. Okay, and it's a shale. If you kind of grab it, and I just grabbed a piece from a little bit up here, it kind of alternates from stuff that's a little bit more competent to stuff that's a little bit more fissile, but I'll show you here. So it's definitely green, it's kind of flaky, kind of shaly. Some layers, some stuff is a little bit more competent than others, okay? But there's that green shale. And if you kind of zoom out again, you can see that it's definitely layered. You've got layers of more competent rock and layers of less competent rock. But you can't really pick out really any sedimentary structures per se. We're not seeing anything like ripples in here. We are seeing sort of these kind of wavy, convoluted patterns. Okay, so that's maybe the one thing you could say about the structure of it, is it's sort of convoluted and deformed actually. Okay, so that's one of the key characteristics of this green shale layer. Okay, so we're still talking about the green shale facies here, and another feature we want to point out are concretions. So up here, in particular, where I'm pointing along this horizon, right here and here and here, here, you see all these sort of globular, kind of almost spherical features in the rock. Those are concretions. And those concretions, when they erode out from the cliff face, they end up here on the seafloor. And I've got one here, a pretty big one. It's super heavy, it's about 50 pounds. And you can see in the little demonstration that what the mineralogy is as we drop a little bit of acid on it. So that's what it looks like in the field, and you can see what it looks like in the lab as well. Okay, so I'm standing on top of the green shale that we just talked about, and now we're going to look at this package of rocks right here, right from here to up to about here. So this is the black shale. Okay, so it's definitely a shale. As you can see, it's fairly easy to pick out. I can pull these flakes out almost just like pages of a book almost. It's so fissile. Look at that. It's just these super flaky black shaly material. Okay. Now the one thing before we talk more about this rock, one other thing I want to point out that's really key is if you look right here, there's this knife sharp contact between the green shale down below and the black shale up above. It's just absolutely knife sharp right here. And you can trace it all the way along this exposure. And once you train your eye to look for that, you can see it all the way around, and it repeats. There's one horizon right here. And as we go up, I'll point out some more, and you can trace them all up and down the length of this outcrop. So one other thing about this rock that's really important, it's black, and it has really high organic content. So it has TOC, or total organic carbon, of a few percent, about 1 to 2%, right? And in other locales where this rock occurs, it actually sometimes contains oil, okay? So the age equivalent formation, called the Albert Formation in New Brunswick, actually contains oil, okay? So parts of this rock, or age equivalent units of this black shale, is actually a source rock for petroleum systems in the Maritimes. Okay, so just a little bit more about the lithology of this rock. We're looking at this shale, and if you can zoom in, you can see this very, very fine lamination character to it. Okay, so it's sort of expressed just in the way that you can pull the layers of rock out like this. But sometimes you can see sort of a nice smooth face, and you can actually see the layers expressed really, really nicely. These laminations of, they're about 1 millimeter to 2 millimeters in thickness. Okay, so that's really the only structure that we see in this rock per se, just the very, very fine scale laminations. We're not seeing any ripples or cross stratification or cross bedding. We're not really seeing any erosional structures. We're mostly just seeing the laminations, and that's it. And we're not seeing anything else there in terms of other biological features, but there are in fact tons of fossils in here, microfossils, right? Ostracodes is one of the fossils that's found in here. So if you split these rocks apart, and if you were to look at them under a microscope, you would no doubt see just tons of ostracodes. And another thing that's found here in these rocks, in this black shale, quite commonly is fish remains. Fish scales, especially, tons of fish scales. Rarely, you might find more parts of the fish preserved, jaw bones, for example, or vertebrae. But most often you find fish scales in ostracodes. Okay, so here we are. We're just a little bit further inside of this little embayment of the outcrop. And so I'm standing, my foot's on the top of the green shale. Here's that knife sharp contact between the green shale below and the black shale above. So this is all black shale from here on upwards. And as you get towards the top of the black shale, you start to see these little packages of rock here and here, okay? So they're a little bit more competent, right? They're not laminated like the shale is. It has a different color, so it's brown, sort of buff colored. And you see that they're sands. We'll show you some close-up photos. You'll see that the lithology is indeed coarser grain. It's a sandstone with some silt as well. You can see here, in fact, that there's this overall coarsening upwards progression. Okay, so it starts out really, you've got the very, very fine grain black shale, and as you move up to it, you start seeing these layers of that sand. So at first very thin, like this. It's a couple of centimeters. Okay, they're sort of interspersed or interbedded with the black shale, and you occasionally get thicker layers like this one right here, and those layers become more and more frequent as you go upwards. Okay, so you can see, I can sort of trace it with my hand, just the shape of this erosional structure in here that's a reflection of the coarsening upwards of the sand. Okay, so I'm even further back into this little embayment of the outcrop, just a couple feet above where I was standing before. So here are the sand layers down below, the brown colored sand layers, and they're starting to grade into this material, which is more green shale. Okay, it's kind of green colored. Okay, so it comes up like this, right? So it's a fairly smooth transition from the sandy layers up into the green shale. And then if you can see right here, there's a very distinct boundary. Okay, it's another contact between the green shale right here. This is all green shale, and then the black shale up here. Okay, this black shale, it's not quite as obviously black as the other black shale, but this is definitely a different facies. This is definitely the black shale facies, the green shale facies, and another knife sharp contact separating these. And you can trace it. You can trace that contact all the way down this part of the outcrop, and I can trace it as far as I can see down over the next 100 meters or so. Okay, so we're down here on the seafloor, and we're just surrounded by hunks of rock that have eroded off the cliff face. And as you walk around amongst these rocks, you can find all sorts of really interesting features, sedimentary structures, tons of erosional structures, and all sorts of other features as well. Some other things that we see are ripple marks. So here's just one example. We're gonna go further down the beach where there's some much better ripple mark examples, but I wanted to just show this one here. This one is trace fossils. So this is, you see all these features here. These are what's called paleophycus. It's a trace fossil. So these are worm-like organisms that sort of move along the surface of the sediment, and they leave these sort of tubular infilled structures that are flat with the sedimentary layering. Right here we've got some tool marks in the sediment, so something that got dragged along, a stick or a stone that got dragged along the soft sediment, and the impression got preserved as a tool mark. Okay. And over here, this one you can't see quite as well, but you've got some mud cracks in that piece of more shaly material. Okay, so we're standing on the seafloor again. We're about 30 meters out from the cliff face, and we're standing on top of a sand unit that's part of the bedrock. It's in place, and you can actually trace this layer of sand up towards the cliff face over to your right, which is to the west. And it's actually dipping down towards me into your left, which is towards the east. Okay, so this is a sand layer. Okay, you're only looking at the top 10 to 20 centimeters or so. It's you can feel it if you were able to feel it. You could confirm that it is indeed sand as the lithology. And if you can come over here just a little bit. On top of this unit, you just see these beautifully preserved ripples. Okay, so they're oriented like this. Okay, there's one ripple crest here, another one. They're pretty well straight crested. They're fairly symmetrical, so they're not asymmetrical. They're not indicating flow in one particular direction. They're pretty symmetrical. And they're planed off at the surface. And it looks like someone took a giant piece of sandpaper and just sanded them off. So that suggests that these ripples, after they were formed, that they were actually exposed at the surface shortly after they were formed, and they were smoothed off like that. Okay, and if you had a compass here, you could actually line your compass up, and you could get a direction of the oscillating flow in this case, because again, these are symmetrical ripples. So the flow must have been flowing in this direction back and forth, normal to the direction of the ripple crests. Okay, so again, we're here at the seafloor surface. We're standing on top of these sandier units, and I just want to point out something that's kind of unusual here. You only really see this in this particular location. You see this sort of saucer-shaped feature behind me. It's about 10 meters, 5 to 10 meters in diameter, kind of circular, this saucer-shaped depression and they actually repeat. So this is the first major one, and then there's another one just beyond that, and then another one and another, and there's at least 5 or so that you can trace out along this layer as it dips out towards the sea. So we call these collapse structures. We don't exactly know what caused them, but some kind of event caused the sediment to just collapse into these saucer-shaped formations. And it's really interesting that it's just along this one particular horizon that they show up so obviously. So when you look at the drone imagery, and also when you look at just the straight up Google Earth imagery, you can see it, that it's associated with this one particular layer that you can trace out to sea.